Okay, now in this video I can probably knock out a few solutions or a few problems. Okay, so part A is what are the equilibrium solutions? Okay, so this is the direction field. So the equilibrium solutions are going to be the solutions where the derivative is equal to zero. Or equivalently where it's not changing as time changes. So remember, this is the t-axis and this is the x-axis. Well, there's only one. It's going to be this one right here. Okay, so part A, the equilibrium solution is just going to be the solution x of t is equal to 0.5. Okay, so now we have to determine whether it's stable, unstable, or semi-stable. Okay, well, by the direction field, we know that if you start at 0 at least, you're going to go away from 0.5. If you start at 1, you're going to go away from 0.5. Okay, and remember the sign of f of x is going to be constant here. Through this range, the sign of f of x is going to be constant. So again, we're considering the differential equation x prime is equal to f of x. This is an autonomous equation. Okay, that will be said explicitly on the exam, but here you can tell it's autonomous because the vectors are constant for horizontal, constant across horizontal lines. Okay, all right, so since it's autonomous, we know that the sign, we know that f of x is 0 at 0.5. So this tells us f of 0.5 is equal to 0. Remember, that's another thing that it means to be an equilibrium solution. So it means the sign of f is going to be constant here, which means even if you start way up here, the sign is still going to be negative. It might not be as negative, but it's still going to be negative. And similarly, even if you start really close to 5, the sign is still going to be positive. Okay, so this tells us that no matter how close you start to 0.5, you're always going to go away from it. If you start a little bit below 0.5, if a solution starts a little bit below 0.5, it's going to go away from 0.5. If it starts a little bit above 0.5, it's going to go up and away from 0.5. So this is unstable. Okay, and there's only one, so that's it for this problem. If we go on to problem 3, again, we're going to do the same thing, same idea. So if I want to know the equilibrium solutions, I need to find the solutions. I need to find where the vector field is equal to 0, or where the vector field is flat. So that's going to be at 0, and that's going to be at -3. Okay, so along this line, the vector field is flat, meaning the solution is constant there, meaning the derivative is 0 there. Okay, so A will have two equilibrium solutions. I'll call it x1 of t is equal to -3, and x2 of t is equal to 0. Okay, now for part B, so if I look at x1, so this, again, the arrows are if you start a little bit above 0, the arrows are pointing away. If you start a little bit below 0, the arrows are also pointing away. So this is unstable. Sorry, I did 0 first. So that was the 0 stable solution. So x2 equals 0 is unstable. Okay, and now if I look at 3, x1 of t equals -3. This is actually a little bit difficult to tell on this picture, but these arrows are actually going up here. You can just barely see them. Okay, and these arrows here are going down. Okay, so if you start a little bit below 3, the solution will go up to 3. If you start a little bit above 3, the solution will come, or -3, the solution will come down to -3. So this is stable. All right, so let's look at this problem. By the way, it's interesting. So I used MATLAB to draw these vector fields, and it actually took me a long time to get the arrows looking reasonable. All right, so that's why I'm just reusing it from the last time I taught this class. Okay, so equilibrium solutions, again, it's going to be 3. It's going to be where the derivative vector is flat. Okay. I mean, remember what we think about the direction fields. I mean, remember what's going on. So let me just say something that's not really related to this problem. But the idea is the vector field lets us tell how the solutions go. So if a solution starts here, then it's going to follow this vector field down like this. Okay, and so if a solution starts at 3, if it just follows the vector field along, well, it's always going to be flat. So it's going to stay constant for all values of t. Anyways, that was just a little way to think about, to sort of connect some of the stuff we've talked about. Okay, so A, to answer part A, x1 of t equals 0, x2 of t is equal to 3. These are the equilibrium solutions. Okay, B, I'll do x1 of t first. So is it stable or unstable? Well, if you start a little bit below 0, the vectors are pointing up. If you start a little bit above 0, the vectors are pointing down. And so x1 of t equals 0 is stable. And for similar reasons, x2 of t equals 3 is unstable. Okay, so let's look at this one. So again, let me graph the stable solutions, or the equilibrium solutions. That's an equilibrium solution. That's an equilibrium solution. That's an equilibrium solution. And that's an equilibrium solution. Okay, so x1 of t equals 0. x2 of t is equal to 1. X3 of t is equal to 2. And x4 of t is equal to 3. These are the equilibrium solutions. Now let's do stability. Okay, so x1, in other words, that's the 0 solution. So this is x1, x2, x3, x4. So x1 is unstable because the vectors are pointing away from it. x2 is stable because the vectors are pointing to it. x3 is unstable, and x4 is stable. Okay, let's see if I can get on to the next one. Okay, this will be the last one I do in this video. Okay, so let me, again, just draw through the stable or the equilibrium solutions. This is 1. This is 1. This is 1. And this is 1. Okay, so for part A, x1 of t equals 0 is a stable solution. An equilibrium solution. x2 of t equals 1 is an equilibrium solution. x3 of t equals 2 is an equilibrium solution. And x4 of t equals 3 is an equilibrium solution. Okay, now for part B, let me look at A. Let me look at x1. So x1 of t equals 0. Notice that if you start below x1, if you start below 0, then the vectors there are positive. The derivatives here are positive. The slopes here are positive. However you want to describe it. But note also, if you start above 0, that the derivatives there are going to be positive. So this means x1 is semi-stable. If you start a little bit below 0, solutions will go up to 0. If you start a little bit above 0, solutions will go away from 0. Okay, now x2. So this is x1, x2, x3, x4. So if you look at x2, this is stable. x3, again, this is x3 of t. x3 is unstable. And then x4 is stable. x4 is stable because if you start a little bit below 3, the solutions go up. If you start a little bit above 3, the solutions go down, so x4 is stable. Okay, that's it for this video.